When it comes to more complicated equations, we want to use this outline of the steps to follow in the solution process. Step 1, simplify each side of the equation as much as possible. That usually involves using the distributive property, commutative property, associative property. Step 2, collect all the variable terms on one side of the equation and all the constant terms on the other. As you'll see, that step involves the addition property. Step 3, use the multiplication property to get just one x alone on one side of the equation. Step 4, check your solution in the original equation. So we simplify each side, use the addition property to separate the variable terms to one side, constant terms to the other, then we use the multiplication property. I'll show you what I mean. Here we have an equation 6 times x minus 3 equal negative 6. We need to start by separating the terms over here by using the distributive property. So 6 times x is 6x. 6 times 3 is 18. So that's what I do first. Now I'm going to use the addition property. This is a variable term, that's a constant term, and that's a constant term. I want all the variable terms over on the left side and all the constant terms on the right side. So I need to add the opposite of this term to both sides. 6x minus 18 plus 18 equals negative 6 plus 18. So you can see there I've added 18 to both sides. 6x plus negative 18 plus 18 is simply 6x, and the negative 6 plus 18 is going to be 12. Next I use the multiplication property. 1/6 times 6x on the left side, 1/6 times 12 on the right side. 1/6 of 6x is x, 1/6 of 12 is 2. So I get x equal 2 for that solution. Now before I leave this problem, I want to check the solution, this solution x equal 2, back in this equation. So I'll substitute x equal 2 into this equation. I get 6 times 2 minus 3 equal negative 6. 2 subtract 3 is negative 1. And I end up with negative 6 equal negative 6. So you can see I get a true statement. That means that I was correct in my solution process and got x equal 2. If I found out that I got a false statement right here, I would go back and check my work to see that see where I'd made a mistake and gotten the wrong solution. Simplify each side first, addition property, multiplication property, there's your solution. Check it. Here's our next problem. 7y minus 3 is equal to 4y minus 15. Variable term, constant term, constant term. Variable terms have the variable in them, constant terms do not. So what I want to do is get all the variable terms on one side and all the constant terms on the other. So I'm going to start by getting rid of this 4y that's on the right side of the equation. To do that, I'm going to add its opposite, negative 4y, to both sides. So you can see that here I'm adding a negative 4y to both sides of the equation. It's okay to do that with the addition property of equality. I can add the same quantity to both sides of the equation anytime it's convenient for me. Now 7y plus negative 4y is 3y. Minus 3 is equal to 4y plus negative 4y is 0. So see, I've succeeded in getting rid of the y's that were on the right side of the equation. All that's left is negative 15. Now I'll add 3 to both sides. Again using the addition property, and so I have 3y plus 0, which is 3y, is equal to negative 15 plus 3, which is negative 12. Now, 3y is equal to negative 12. I multiply both sides by 1/3. And maybe you can see that solution already. 3 times what is negative 12? Of course, the answer has to be y is equal to negative 4. So y equal negative 4 is the solution to that equation. It took me 2 applications of the addition property to get all the variable terms on one side and all the constant terms grouped together on the other side. Once that was done, it's a simple application of the multiplication property to get that solution. Here's another example. 2 times 3x minus 6 plus 1 is equal to 7. Let's multiply using the distributive property. 2 times 3x is 6x minus 2 times 6 is 12 plus 1 is equal to 7. 6x plus negative 12 plus 1 is 6x minus 11. Is equal to 7. So there it took me 3 lines to simplify both sides as much as possible. I don't want to use that addition property or multiplication property until I have simplified each side as much as I can. Now I'll isolate x, all the variable terms with x in them on the left side, and put the constant terms on the other side. 6x minus 11, that's right, I have to add 11 to both sides. 6x plus 0 is 6x. Now, 6 times x is equal to 18. If I multiply both sides by 1/6, I'll get x is equal to 3. So 6 times 3 is equal to 18, and I can either solve that by inspection, just by looking at it, or I could multiply both sides by 1/6 and get that x equal 3. This will check if I put it back into the original equation. Let's go on to our next problem. It's a little more complicated looking. I'm going to simplify each side as much as possible. So let's start with, let's see, there's not much to do on the left side, so I'll just rewrite it. 9x minus 6. Here I'm going to use the distributive property, and remember I want to take the negative sign with the 3 when I multiply. So negative 3x, and then negative 3 times positive 2 is negative 6 minus 24. 9x minus 6 is equal to negative 3x minus, that's a negative 6 plus a negative 24, which is negative 30. Let's get all our variable terms on the left side, so I'll start by getting rid of the variable term that's on the right side. I'll do that by adding its opposite to both sides. (9x plus 3x is 12x minus 6 is equal to 0 plus negative 30, which is just negative 30. Now I'll add 6 to both sides of the equation. 12x minus 6 plus 6 is equal to negative 30 plus 6. 12x plus 0 is 12x. Negative 30 plus 6 is negative 24. Multiply both sides by 1/12, or you can probably solve this by inspection. There it is, showing the multiplication property. 1/12 of 12x is simply x, and 1/12 of negative 24 is negative 2. So negative 2 is my solution to that equation. So it took 3 steps right here to simplify both sides as much as possible, then 2 applications of the addition property to get all the variable terms on one side and constant terms on the other side. Then it was simply a matter of using the multiplication property to get just 1x. The next 2 equations we're going to solve involve fractions, and we're going to alter the steps in our solution process just a little bit. Here I have x over 5 minus x is equal to 4. Now, I could solve this problem right here by working with the fractions, but sometimes it's easier if we get rid of the fractions in the beginning. So I look at all 3 terms here as if they're fractions. This has a denominator 5, denominator 1, denominator 1. The least common denominator for these fractions is the number 5. I'm going to multiply the left side by 5, and I'm going to multiply the right side by 5. So I use my multiplication property a little bit out of order here. I'm multiplying both sides by the least common denominator first, but the reason why I do it is to clear the equation of fractions. So 5 times x over 5 is just x. 5 times x is 5x, and then 5 times 4 is 20. So you can see 1x subtract 5x is negative 4x equal 20, and then negative 4 times what is 20? X turns out to be negative 5. So this method of finding the least common denominator first and multiplying both sides by it gives us an equation that's free of fractions, and that usually is a little easier to solve. I didn't show all the steps here in the solution process, but you can see that this is not a difficult equation to solve. Let's try one more of those least common denominator problems. 1 over x minus 1/2 is equal to negative 1/4. Least common denominator is equal to 4x. Least common denominator is 4x. So I'm going to multiply the left side by 4x, and then I'm going to multiply the right side by 4x. 4x times 1 over x will be equal to 4. The x's divide out. 4x times 1/2 will be 2x. The 2's divide out. And then negative 1/4 times 4x will be equal to negative x. So I get 4 minus 2x is equal to negative x when I multiply both sides of this equation by the least common denominator 4x. That will help me simplify, or that gives me a simpler equation to work with right here. Let's get all the variable terms on the right side this time. I'll do that by adding 2x to both sides. When I do that, the left side is 4, and the right side is simply negative x plus 2x, which is x. So my solution just falls out real quickly when I use that addition property right there. So these are the problems that you're going to encounter last in the problem set. They involve a least common denominator, and they're a little, and it requires that you use the multiplication property a little bit out of order from the way that you're using it in the problems that come before these.